Hey, good afternoon, everyone. Feel free to come in and sit down. We're going to be going over how our team uses Warewulf to provision AI clusters here at AMD. Before we get started here, we're going to go a little bit over about who we are and our background. My name's Zachary Reid. I'm a member of technical staff, systems design engineer here at AMD. I work in the global cluster engineering group. We work on bleeding edge hardware in R&D environment and work on AI setups here at AMD. Before AMD, I was at Oak Ridge National Laboratory, and I've also been at AMD for almost 2 years now. I'm going to turn it over to Michael Hogan.
My name is Michael Hogan. I'm on the same team as Zach and Massud here. I've been at AMD for about 1 year now, and before that, I came from Argonne National Laboratories.
Hello, everybody. My name is Massud Zaran, SMTS, System Design Engineer, as well on the same team. Prior to this, I've worked at multiple research facilities in the HPC, as well as life sciences, a short stint at a national lab where we were dealing with high energy physics. And 10 years before that was pretty much data centers and enterprise environments. So I would like to touch a little bit about all my, best practices that happened and bad practices in research and why we were choosing Warewulf and the little bits that we had to dive into. So there were scenarios where you would have users using Slurm clusters, but somehow they were all accounts, as well as having that same account with pseudo privileges, and all of these said users were deploying it across, running jobs across the cluster, yet no one knew what was going on. Or, those environments where it's enterprise, so they're looking for a single pane, and in that single pane, it's a hypervisor, yet nobody knows about NUMA controls, memory binding, CPU binding, and wondering why performance is so horrendous. Or about those deployments where jumbo frames was not a thing with storage, and everyone wondered why you're only getting 30 gigs of throughput, and why every failure occurs whenever the cluster is actually saturating that network. We've also been in places where reprovisioning, while you would think, hey, this only takes a couple of hours, you would have someone redeploy clusters, and at times it could take days, and then new hardware would take weeks. And then you're wondering, this is not the normal factor of increase when you're having more people deploy the same systems over and over again. Or about the environments where somehow drift seems to be a normal aspect of it, where every OS is about a 0.1 version off, every package somehow was installed incorrectly, or somehow someone decided to use MariaDB on one node, Postgres on the other, and wondering why the databases weren't talking to each other. We've seen deployments where everything was static, and an adjustment to a kernel would take hours, sometimes days, as well as reconfigurations, whether you had a schema update on a database or just trying to deploy a new system, you would end up realizing this is taking way too long to be a cluster management or cluster managed system. You also had a lot of lack of images. So deployments were done to disk, and they were done in a fashion that never made sense to you. So now we'd like to touch base on the convergence that we're noticing between AI and HPC. A lot of the aspects that we've seen have become reproducibility, whether it's science or just general redeployments and pipelines that are being ran. We noticed that the biggest factor between AI and HPC is that reproducibility and the lack of it at times. We've also seen high-speed interconnects being a thing, whether it's between communication libraries, MPI patterns, nickel, RICL, the same communication systems that everyone gets used to these days. This seems to be pretty much going between both systems as well. Resource managers, whether you're deploying Kubernetes, bare metal, resource allocation, and how they're used in the provisioning systems are going to be a thing and are required between both of these environments. We've also seen monitoring, or we like to call metrics. We don't really care if the system's there in a big cluster. We'll notice when the telemetry is gone, but we need to be able to tell the performance, whether it was on HPC or AI, and much heavily on AI, we see it. It's needed and required. We also have PFS, which is parallel file systems. While a lot of people assume that at a small scale, you don't really need it, when you have hundreds, if not thousands of nodes, you end up realizing that that front end system can no longer handle, NFS and connects, and seeing why you're getting a bottleneck or a failure occurring because of the lack of a parallel file system. And then we like to touch base. So a lot of the HPC stuff that we see is very CPU centric. While there are accelerators, we do see most of the workloads are like, FP64. People are not diving into that realm of saying, hey, let's lower the tolerance and let that workflow do its thing. Very static configs. While there are scenarios where you do need to make adjustments, that things start to drift when you end up making a change and you're not doing it cluster-wide. As well as most of the workflows are very deterministic. The storage systems or the file systems are very sequential data sets. And now when we go into AI, what we ended up noticing a lot is accelerator heavy. So you end up having lower precision. You're able to give a little leeway to end up making better performance. We're taking a slight penalty, but if not, you kind of know how to deal with it. We're seeing more advanced networking, so topologies are changing. Whether you're still using spine leaf, you do see rail topologies. But what we noticed, and it was like a kind of awakening to us, is you're seeing GPUs requiring their own dedicated network cards. In HPC, it's usually front end and storage network. This time, it ends up becoming, mayhem when you're seeing that much throughput occurring and you're seeing buffers getting overflowed. And HPC is so static in a sense that you already know if it's the storage, if it's the network. It can be a mix of both. And then we're also noticing that a lot of the dynamic config requirements. So we do heavily in R&D at AMD. So whenever there is an adjustment, it's usually like, hey, I need to be able to do this in minutes, if not hours. And we do have power users who we want to facilitate. So what we end up doing is pretty much giving them enough steps to be able to handle this themselves, whether it's an engineer or it's an actual, deployment sysadmin. And we're noticing that the data workloads, while LLMs are very text heavy, there are images and videos. And as that data increases, we ended up coming to the conclusion that it's starting to become more and more heavy like HPC as well. So let me hand over to Mike Hogan.
So today you have a lot of provisioning options. You have XCAT, Moz, IPMI, Foreman, 35 USB sticks. And of all these options, there's a reason why we felt like Warewulf was the best suited for our needs here at AMD. So for one, ease of use is definitely a really big one. It's very quick to deploy. It's a very simple architecture. All you have to do is spin up one VM and you can just put Warewulf on it, and now you have your controller node ready to go. Through the use of profiles, definition files, and overlays, which Zach is going to touch on a little later, it's really easy to get your cluster going. You have stateless provisioning versus stateful provisioning, which is still an option. You have multiple kernel versions, so you can test on the fly immediately. And if you run into any issues or snags, you can immediately roll back to a previously known good version. The documentation and community behind Warewulf is also fantastic. There's very verbose documentation to read through. You have integration into other CIQ products already in there. You have active development with really good patch notes, so you can keep up to date on all the new features and changes that are happening. And the support is really nice because you can hop right into the Slack community and you can ask questions directly. You have the option for paid support through CIQ, and then it's also open source, so you can just dig through the code yourself. So I touched on stateless provisioning, and stateless provisioning for our needs we found to be a lot better than stateful provisioning, just because we have one centralized management from that Warewulf control node. You have really quick node deployments where whether you have 8 nodes or you have 64 nodes, you can get them all up in no time. You have a single golden image that you can make all of your changes to, which just means you can make your change and then push it right out with a reboot, and all of your nodes will have that new update. And then on the stateful provisioning side, the reason why we like stateless in our case is because we don't have to do individual node maintenance through the use of dish commands or Ansible. You have slower deployment to disk instead of just running right in RAM. And then you don't run into configuration drift like you might with stateful provisioning. And then when you actually do run into that issue and you have to roll back to a previously known good version, it's a lot harder to do than simply doing a reboot after doing a one-line command change. Now I'm going to hand it over to Zach.
Yep. As Mike mentioned, why we chose Warewulf, I'm going to be going over a high technical overview of how we've implemented Warewulf in our team here at AMD. So my previous experience being in more of a production HPC environment, generally when you deploy a cluster, your OS, your kernel, your high-speed networking drivers, even your storage system, all the firmware and drivers related to that are generally predetermined. Moving more into the AI space, we're constantly changing for the bleeding edge technology. We could be one morning we're at a certain kernel version, by lunchtime we're already updating, or we're moving to a different OS type because of a different customer requirement. So we're constantly changing. And the cool thing with Warewulf is there's multiple different ways you can set it up. You can set it up more in a static approach or more of a dynamic approach, all based off your environment. We found here at AMD within our team, we target more of the dynamic approach. So, speaking of those two options and how you set up your systems, how does Warewulf do that? Well, you got your definition files and your overlays. So here at AMD, we use definition files to set up our OS type, our kernel versions, and our base OS packages. We leave that standard. It's an easily reproducible file that we can house and get. So how do we approach the more modular approach for all the other software that's constantly changing? Here at AMD, we utilize overlays. So some of the things that we'll put into overlays is your high-speed networking driver setups, your AMD GPU drivers, things that are constantly changing in the AI space. We can easily make that modular through overlays. An overlay generally will run during the boot time and or post-boot. So all of the things that we're constantly changing here in the AI space, we'll generally put that in a more dynamic approach into an overlay. So, I've talked about it here at a high-level overview, but, it's really more simple even than just talking about it, because it's generally just a one-line command. You predefined it. Like here we have an example of how we import a definition file. That definition file could be Rocky 8, Rocky 9. You import it from AppTainer. You would build it into Warewulf, reboot your nodes, and then you could simply go from Rocky 8 to Rocky 9 with a simple reboot. A lot of the times we can use a lot of the same overlays from Rocky 8 to Rocky 9 on the post-boot setup with our AMD GPU drivers, our high-speed networking drivers. Something that we don't have mentioned specifically here in this slide, but we also use software modules on NFS file systems for like different ROCm versions. Then we'll tie our AMD GPU versions into our overlays. So like here's an example of a command where we would just change the AMD GPU setup overlay and update to a newer AMD GPU version. You would reboot the node and it would have that version. Another thing that wasn't mentioned in the previous slide, sometimes we have multiple different customer requirements, as mentioned before, multiple different customer requirements, different OS requirements. One thing that we really like to use with Warewulf is a profile setup. So generally speaking, all the configs that you can apply at a single node level, you can apply that to a profile level. So we have multiple customers who will be on a different kernel, different OS type, and the profile allows us to apply all those same parameters to multiple sets of nodes. So generally speaking, if you wanted to manage multiple clusters or multiple systems and sets of nodes with different images, different kernels, different drivers, you can do that through the profile feature with Warewulf. Another great feature that we've utilized that Warewulf has is implementing multiple kernels into a single OS image. So how we implement that, we'll install multiple kernels into a definition file. Warewulf recognizes that after you build the image into Warewulf, and we can easily change kernels on the fly through a single command line because Warewulf will recognize those kernels that are built into the image. So in our environment, we've seen different optimizations for different kernels. So if there's a new optimization that comes out, we can easily just send a one-line command out, reboot the node, and it'll have a new kernel version. And then just speaking about the profiles, that there's the commands that you would run to do that. Rebuild the overlays, you could power reset the node, and then it would have everything there. Kind of to kind of to come to a conclusion here, Warewulf has saved our team countless hours and headache of time. It's been the best thing for our team here at AMD, being in a dynamic AI environment. We would recommend it to anyone that's running AMD GPUs, and it can be done. So now we'll just get into the questions. If anyone has any questions, please feel free to raise your hand at any time. Yep.
Matt, I come from an XCAT, old XCAT guy here. So I remember we would install XCAT and not touch it anymore. Even though we missed out on features we wanted, we were just scared to upgrade the system. So could you go over some of the Warewulf upgrade paths and how that is?
Yes, so upgrading Warewulf is very simple. You can simply use the upgrade, whether DNF upgrade, and point it to the new Warewulf package. Then there's 2 commands you would run after that, and then Warewulf can be updated. It's that simple as far as updating Warewulf goes. You're not necessarily locked in at any time, and it's very easy to do. Does that answer your question?
Could you go over the components like database?
So if you couldn't hear me, he was asking about the components of Warewulf. If it's MariaDB, and what else did you mention there? Oh, so it just uses a flat file system. We've benefited from that here at AMD. We actually host Warewulf from a VMware infrastructure, so we can easily take snapshots. Unfortunately, someone didn't take a snapshot at a certain point in time, and the VMware tanked out. But one thing that's really nice about Warewulf that we was able to do is, because it's a flat file system, all of our configuration files were backed up in Git. So we was able to use those same configuration files that we backed up in Git and redeploy Warewulf within a day and have it up. Yep.
So what's some functionality that you're looking forward to or hoping or that would benefit your team that isn't in Warewulf today, but that you'd like to see in it?
That's a really good question. I think it's a little opinion based, but I really love Warewulf, and it's really the tool that I like. You know, it's like Mike mentioned, it's got a great Slack community. Everyone's always supporting it. They came out with the Warewulf Pro. We've actually deployed that in our environment, which is more GUI based for those admins who are not comfortable with CLI. It's a really hard question to answer for me because Warewulf has everything I need from a system engineer and system admin perspective.
Yeah, I guess expanding on that aspect of it, a lot of our methodologies are usually around separation of concerns. And I feel like Warewulf does what it's intended to do very well and very fast, and it's not trying to be like everyone else. If we want monitoring, we know how to deploy it, and we will use the monitoring stack that we want. We do not need to see a unified dashboard with it, as well as if we were trying to use Aptainer or Ascender, we'd rather have the separation. Our worry is always you're going to deploy something and it crashes. It's going to crash everything. And how are you going to get the monitoring system to actually alert when the thing crashes if it's all in one giant monolithic system? That's my biased opinion.
So for monitoring, how would you actually set that up with Warewulf? Or can you?
So in the monitoring aspect, what we usually do is we leverage the overlays to be able to deploy Prometheus exporters. Again, I'm very big on separation of concerns. So I'd rather have Grafana and Prometheus do its own thing. It would be great if you were able to use, say, an exporter into Warewulf Pro and have the dashboard there, but you still have that same conclusion I always come to is if it breaks, I want to be able to go into the system itself. So the great thing when you're deploying, say, Grafana or Prometheus is if Grafana breaks, Prometheus is still there collecting metrics, and then vice versa. You can also tell from Grafana when Prometheus as a data source disappears. So being able to utilize and leverage Warewulf as pretty much your configuration management when you're deploying these systems, you're able to easily update those Prometheus instances, those exporters, and a lot of what we do in R&D over here at AMD is we make custom exporters. So there is no package somewhere that you're pulling. So you're going to have to pretty much, like I like to say, is MacGyver Warewulf to be able to deploy this in a very seamless fashion. So when an engineer comes in and he's like, I want to make an adjustment, it's just change this version, change this flag, and you're done.
So I know you are presenting from a user perspective and not from CIQ themselves, but I have a question like, can you parameterize, or is there a uniform way to parameterize these overlays? Because I see, let's say a trivial example would be, I want to change the FS tab, but they have UUIDs per disk, or so that really changes per node. Or also UDEF rules with different devices. We have a hybrid cluster with AMD MIs, but also NVIDIA Teslas. So we need to adapt depending on some parameters. And in general, you need some kind of parameterization in these configurations. So I'm curious how you do that. Or do you have a completely uniform cluster?
So I guess we would be like the advanced power users. Before we dive in, Zach, real quick. So a lot of times there's an instance, say like with slurm D, you want the node to be able to pick up egress. We're tricky enough, I would say, to figure out of how to be able to like grep out the subset of the slurm D to be able to give us the egress and then use the dynamic config. So there's a lot of understanding of the underlying systems and being able to adjust this, but there's also expansions. And this is me just being like, I think I could program, so I'll try to program the feature I shouldn't be doing. No, and that's why I was going to pass it on to Zach to tell the real best practices.
Well, specifically talking about the FS tab and your mount options, your UIDs and GIDs, making sure that all is aligned. One thing that's correct me if I'm wrong, anyone, but it's somewhat that we use in Warewulf now. I believe we used to just use it in a standard overlay, but Warewulf has actually mount options that you can apply to it at a node level or a profile level. And generally speaking, we'll apply that at a profile level, which is maintained across all of those nodes.
So the overlays can contain static files that are just files that go out to your nodes, but it can also contain templates that are generated per node based on metadata from the node. And there's a standard set of metadata that the nodes have that are just part of the Warewulf definition of a node, but that includes an arbitrary set of key value tags that you can define. And we also recently added a resources system that lets you have arbitrarily nested metadata. So you can invent your own metadata, attach it to a node, and then your overlay can be built based on what overlay or what metadata comes in either via a profile that groups nodes or even individual nodes.
Any other questions? I would really like to thank everyone for coming to our presentation. I would like to thank the employees that's helped us here at AMD come up with this. I would like to thank CIQ for letting us present. I hope you all have a great day. Thank you.